In this lesson, we're going to be factoring perfect cubes. We've done perfect squares before, but now we're going to do perfect cubes. So there's two formulas that you will need to know for factoring these, but I'm going to show you how to remember them. It's not very difficult. But one is for the sum of perfect cubes, and one is for the difference of perfect cubes. Remember, sum is adding, difference is subtracting. So I want you to notice there's two things you're going to multiply: a binomial times a trinomial, 2 parts times 3 parts. 2 parts times 3 parts, no matter which type it is. And then notice that the a and the b are just the cube root of that first number and the cube root of the back number. That's the same for both of these. Now, the front of the trinomial is going to be the square of the first number. So you're going to square the front. The back number is the second number squared. All right, and this is multiplied together, the two values together. All right, notice they're the same on both of these, right? What is changing, however, is the sign. So pay attention to this. If the sum is right here, sum always starts with a plus, then it goes plus, minus, plus. Alternates, right? Now, with the difference, it goes minus, plus, plus. So how do you remember that? Well, this back one is always going to be a plus sign. So make yourself a note. Always add this back one, all right? And these will alternate signs. But if it's a difference, then you start with the difference. If it's a sum, then you start with the sum. So hopefully that kind of helps you remember the formulas. So let's try one of these. A perfect cube, x cubed minus 27. Well, let's think about what is the cube root of x cubed. Hopefully you remember that that's just x, right? And what's the cube root of 27? Well, that is 3. So if it's the difference, there's a minus sign of the cube roots. Now, let's figure out the trinomial in the back. Remember, the front is always that first value squared, so it'll be x squared. The back is the last number squared, so negative 3 times negative 3 is 9. The middle is them multiplied together, so it's 3x. Now let's play with our signs. If it's a difference in the front, then it's a plus, and the back is always a plus. And that's it. That's all you have to do on this. Let's look at number 2. Now, this doesn't look like a perfect cube as it is, but if we do GCF first, maybe it will be. So let's see what happens. If we take that 3 out, we'll have x cubed plus 1. And now x cubed has a perfect cube, and 1 is a perfect cube because 1 times 1 times 1 is 1. So that 3 just kind of hangs on for the ride. So the cube root of this is just x, the cube root of this is 1, and it's a plus sign, so I bring that plus sign down. Now remember, the front here is going to be the first term squared, the back is the back term squared, and the middle is them multiplied together, so it's just 1x. Now we change the sign, so it goes plus here, minus, and the back is always a plus, and this would be my final answer. Now these are perfect cubes. Not all of them will be perfect cubes today, but I just want to show you how to handle it when they are. So let's just remember some things that we did before when we did factoring. Review, remember this one is a difference of squares. Remember, a difference of squares means it's a minus in between them. Now we didn't have the sum of squares, we just had the difference of squares. So difference of squares, remember, we could factor those by taking the square roots, and one was a plus and one was a minus. This was back last semester. That's the difference of squares. Now, you can't do the sum of squares. This is the sum of squares. This doesn't factor. You can't go any further than this, so this is your answer. You cannot factor a sum of squares. You can factor a sum of cubes. We've shown that here. Let's try a few more reminders. Look at these. It says to factor and identify the linear factor. Remember, linear factor means x to the first power. Quadratic factors would be x to the second power. So let's just look at this. Here we have 4 terms. So remember, when we had 4 terms, we did that grouping thing. Okay, so let's look at that grouping thing and see if it works. So we take these first two. What's the GCF of those? We can take x squared out, and we'll have x plus 3. Bring that plus sign down, and then we'll take the GCF out of these two, so we'll take a 5 out, and we'll have x plus 3 again. Then we can rewrite them. These two are repeated, so I'm going to say x plus 3 times what's left over is the x squared plus 5. So this is my answer, right? Now, this part right here is linear because it has x to the first power. This part, since it's x squared, is quadratic. So I'm asking you to identify the linear portion of your answer. Let's try number 4. Same process again. Let's group them. So first two terms, I can take a 2 and an x squared out. That will leave me with x minus 10. Bring that minus sign down, make it a 1, since I can't take anything else out. That gives me x minus 10. Now when I group them, I'll have x minus 10 times 2x squared minus 1. All right, so if I mark it here and identify my linear, all I have to do is just draw myself an arrow and label it as linear. That's really all there is to the rest of the assignment. So some of your problems will be cubes, perfect cubes, like I showed you at the beginning. Some of them will just be grouping like this. Good luck. We'll see you in class.